Welcome back to the deep dive. Today, we're tackling something fundamental. We're digging into the bedrock of pretty much everything in digital defense.
That's right. We're looking at information security governance and enterprise risk management, or
Yep.
ERM.
Exactly. We get stacks of frameworks, governance docs, risk models. Our job today is to kind of distill that down into clear strategic insights for you. This is about the foundation.
Yeah, and this isn't, a super technical dive. We're not looking at code today. We're synthesizing the core ideas,
Right.
the why and the who behind security decisions.
Right. Moving beyond just the technology and into the strategy.
Absolutely.
Yeah.
If you're trying to understand how security fits into the bigger business picture, well, you have to get your head around this stuff. It's foundational, like Domain 1 material and certifications.
We need to understand accountability, the language of risk.
And how organizations decide what risks are, well, acceptable.
And I think the big takeaway right up front is that good governance isn't just a cost center. It's not just defense.
No, not at all. It's actually an enabler for the business.
That's the key point. We think protect assets, but really it's about enabling success. It lets organizations confidently take chances, chase opportunities.
Because they understand and are managing the risks involved. It's about making calculated decisions, not just reacting out of fear.
Okay, so let's dive into that core purpose. Section 1, governance and the classic CIA triad.
Right.
If someone asks you, point blank, what's the #1 goal of an information security program, strategically speaking?
The answer has to be strategic risk management. Simple as that.
Reducing organizational risk to an acceptable level.
Exactly. Reducing those risks related to information systems, data, down to a level that senior leadership has formally signed off on. And crucially, it must align with the business goals.
It has to support the mission, not hinder it unnecessarily.
Precisely. If your security program is just creating friction, slowing things down without a proportional risk reduction benefit, well, it's failing, isn't it?
That makes sense. You also mentioned program versus, say, a project. Why is that distinction important here?
Yeah, good point. We throw those terms around. A security project, that's finite. It's got a specific goal, a start, an end, like rolling out MFA.
Okay, temporary objective.
Right. But the security program,
Yeah.
that's the big picture. It's ongoing. It's the whole strategic wrapper. It includes all the policies, the processes, the oversight, all the projects.
And it ensures those projects actually tie back to the overall risk strategy.
Exactly. It's the long-term continuous effort to manage risk and adapt.
Okay, so that's strategic focus. That leads us straight to the core principles, right? The CIA triad, confidentiality, integrity, availability.
The 3 pillars, the absolute bedrock. Everything else kind of flows from these.
Let's break them down quickly. Confidentiality.
Preventing unauthorized access or disclosure. Secrecy, privacy. Think access controls, encryption, data masking, that sort of thing.
Got it. Integrity. This one sometimes trips people out.
Yeah, it's not just stopping changes. It's ensuring data is accurate, complete, and trustworthy. Unaltered, basically, whether it's stored, being sent, or processed.
Crucial for things like financial transactions.
Absolutely paramount. You have to trust the data hasn't been messed with accidentally or maliciously.
And the third, availability. Seems straightforward, but critical.
Oh, definitely. Ensuring authorized users can get to the systems and data when they need them. Think business continuity.
In today's world, downtime is expensive.
Hugely expensive.
Yeah.
Minutes can mean millions. So if security measures kill your uptime without really good reason, you're working against the business mission again.
Now, you hinted earlier, these three don't always play nicely together. There's a tension.
A constant tension. It's often a trade-off. Maximize confidentiality, maybe with super strong encryption, multiple authentication layers.
You slow things down, you impact availability.
Right. You increase overhead, make it harder to access, even for legitimate users.
Yeah.
Flip side, maximize availability, strip away complexity.
And your confidentiality and integrity controls get weaker.
Exactly. Finding that balance based on the organization's specific risk appetite, that's the art of security architecture.
And speaking of derived concepts, while CIA is the core triad, there's another important one, especially for high-stakes stuff, non-repudiation.
Yes, non-repudiation, crucial. It's the assurance that someone cannot deny having done something.
Like approving a big payment or a major code change?
Precisely. Anything with significant financial, legal, or operational impact. You need undeniable proof of who did what when.
And how do you achieve that? It relies on the others, right?
It does. It needs strong integrity and authenticity. Think digital signatures, reliable timestamps, really detailed audit logs. The system has to provide that proof.
Okay, so that defines what we protect. Now, how about the how, the structure, security architecture? You mentioned it's not just tech.
Definitely not. It's conceptual. It covers 5 distinct viewpoints, and you need all of them for a holistic approach. Skipping levels means you miss critical context.
So what are these 5 perspectives?
Okay, top down. First, contextual. This is the why. Business requirements, mission regulations, market pressures. What problem are we solving securely?
High-level business drivers.
Exactly. Second, conceptual. Still high-level design. The main security domains, boundaries. What are the major moving parts? Abstractly.
Got it. And
Third, logical. Now we're getting more technical. System relationships, data flows, network topology where security services sit. VLANs, segmentation strategy, that kind of thing. How do things connect?
Okay, the blueprint level.
Kind of. Fourth, physical. This is the tangible stuff. Server locations, locks on doors, cabling, cameras. Where is it physically? How is that protected?
Makes sense. And the 5th?
Fifth is management. This is the governance layer again. Policies, procedures, incident response plans, personnel security. How do we make sure people actually follow the rules? How do we manage the human element?
So the physical perspective might be the server cage.
yeah.
But the contextual perspective explains why the data in that server needs a cage in the first place, tying it back to a business need.
You got it. And often the most effective controls aren't the techie ones. They're administrative.
Like policies.
Policies, procedures, and crucially, security awareness training. It's a vital administrative control. It tackles the biggest variable people.
Human error. Phishing.
Always top of the list. Training is often the most cost-effective way to mitigate that huge chunk of risk.
Okay, this leads perfectly into Section 2. Accountability, roles, the whole governance structure.
Right? Who's responsible?
And the source material is crystal clear. Without senior leadership sponsorship, security programs are basically dead in the water. Why is that backing so non-negotiable?
2 words. Authority and resources. IT can't grant itself either of those across the entire organization.
Policies need clout.
They need to be approved by senior management, CEO, someone high up to have any teeth. Otherwise, they're just suggestions. Security requests get ignored for speed or cost savings.
Needs that top-down mandate.
Absolutely. And at the very top of that pyramid, the board of directors, the 5th line in that expanded model.
Their role isn't day-to-day operations, it's strategic oversight. What's their unique critical function?
Defining risk appetite. That's the big one. They decide strategically how much risk the organization is willing to take to achieve its goals.
That sets the boundaries for everything else.
Everything. Without the board defining appetite, the CISO, the security teams, they're just guessing, flying blind.
How does a board actually express this appetite? Is it just a feeling, or can they put numbers on it?
It really needs to be quantifiable to be effective. You might hear qualitative stuff like, we have a low appetite for risks impacting brand reputation. Okay, but what does low mean?
Needs to be measurable.
Right. A more rigorous board will demand metrics, maybe a dollar amount. Annual cyber losses must not exceed $10 million. Or service impact, no more than 30 minutes unplanned downtime for core customer systems.
And regulators are pushing for this now too, more board involvement.
Definitely. Bodies like the SEC are emphasizing board competency. They can't just passively receive reports anymore. They need to understand, challenge, and provide real oversight on risk.
Okay, so the board sets the tone. To manage that, the org structure needs to avoid, well, conflicts. Which brings us to the classic CIO versus CISO tension.
Yes, the inherent conflict. And it's necessary in a way, but needs managing through structure.
So the CIO is focused on
Execution, efficiency, speed, getting projects done, keeping the lights on. They're the builders, the operators.
And the CISO.
The CISO's job is protection. They introduce security requirements, controls, processes that often prioritize security posture over pure operational speed or cost, which naturally can cause friction.
So if the CISO reports to the CIO,
You've structurally prioritized operations over security. The CISO is constantly pressured to compromise. It's a built-in conflict of interest.
which is why best practice often sees the CISO reporting elsewhere.
Exactly. To the CEO, maybe a chief risk officer, sometimes directly to the board or a board committee. An independent channel is key for objective security advice.
And this structure gets formalized in those lines of defense models. 3 lines or sometimes 5.
Yeah. The model has evolved. The classic 3 lines are.
Operational management. They own the risk day to day. They're doing the work.
Okay.
Second line, risk management functions. They guide, monitor, set policies. The CISO's team often sits here. They help the first line manage risk effectively within the rules.
Right. Oversight and guidance.
Third line, internal audit, independent assurance. They check if lines 1 and 2 are actually doing what they should, if controls are effective.
So where do the other two lines come in? The expanded view.
The fourth and fifth lines highlight what the three-line model sometimes implicitly assumes.
Executive management. They provide the resources, the buy-in, champion the culture. They connect the board strategy to the operational reality.
Crucial for making it happen.
Absolutely. And the fifth line, the board. As we said, ultimate oversight, defining appetite, providing that independent challenge function.
So the 5 lines really emphasize that top-level commitment and strategic direction are essential. It's not just about the doing and checking.
Precisely. That's what elevates security governance from tactical checks to strategic imperative.
All right, section 3. We need to get the language right. Risk appetite, risk tolerance, risk capacity. These get mixed up all the time.
They really do. And confusing them leads to muddled decision-making.
What's the biggest mistake people make differentiating appetite and tolerance?
Using them interchangeably. They're related, but operate at different levels. Let's start with capacity. That's the absolute max.
The ceiling.
Yeah, the total amount of risk the organization can possibly handle before, failing completely. Going bankrupt, mission failure, exceed capacity, game over.
Okay, pretty stark. Then appetite.
Risk appetite is broader, more strategic, often qualitative. It's the desired level of risk the board says we're willing to take to achieve our goals. Like, we'll accept moderate risk for innovation, but minimal risk for financial reporting.
So the strategic statement.
And tolerance.
Risk tolerance makes the appetite concrete. It's the acceptable range of deviation from that appetite, usually quantified. It puts numbers on the qualitative statement.
Can you give an example? Sure. Appetite might be. We aim for high availability of our e-commerce platform. Tolerance could be. Unplanned downtime must not exceed 0.1% per month, or transaction processing times must stay below 2 seconds 99.9% of the time.
So tolerance is the operational metric the CISO works with day to day.
While appetite is the strategic guide from the board, tolerance measures how much variance from the appetite target we can live with.
Got it. That quantification then leads us to the operational triggers. Risk limits and risk thresholds. This is where it gets real.
This is the nuts and bolts, yeah. Think of it like traffic lights for risk.
Okay.
A risk threshold is like the yellow light. If you cross it, it triggers a specific action, maybe an alert, an investigation, requires a manager to look into it. It's an early warning signal.
Heads up.
Exactly. But a risk limit, that's the hard red line. Hit a limit, and it demands immediate serious action. Maybe stop a process, trigger a major incident response, get the board committee involved now.
Limits mark the boundary between acceptable deviation and unacceptable exposure.
Right. Crossing a limit means you've gone beyond your agreed tolerance.
Let's use that Spectre meltdown example you mentioned. How did limits play out there?
Oh, it's a perfect illustration. The organization likely had conflicting limits. A security limit, something like critical patches applied within 48 hours.
Okay, very common.
And an availability limit may be no more than 0.5% of systems rebooted unexpectedly per week.
Right.
When those early Spectre meltdown patches came out, they were unstable. Caused lots of crashes and reboots.
So patching within 48 hours meant?
They would definitely blow past their availability limit.
Yeah.
Huge numbers of machines would crash. But not patching meant violating the security limit. A direct conflict.
So what happens then? Management can't just pick one.
Not if the limits are properly governed. This conflict must be escalated, usually to the board risk committee or an equivalent senior body. They're the only ones authorized to approve exceeding or changing a limit.
So they had to ask for permission to delay patching.
Exactly. They'd present the data. Here's the security risk of delaying. Here's the operational risk of patching now. We recommend a temporary increase in the patching limit to 7 days while vendors stabilize the fix.
And the board committee weighs that trade-off.
They weigh the trade-off, document the decision, and approve the temporary deviation. It shows limits aren't just static rules. They are critical decision points, forcing executive engagement on strategic risk choices.
That really highlights why risk management needs to be continuous, doesn't it? And applied everywhere. You mentioned 3 tiers.
Yeah, NIST and others talk about applying it across. Tier 1, organization-wide strategy. Tier 2, mission business processes. And Tier 3, individual information systems. It has to connect.
And the process itself has core steps. Framing, assessing, responding, monitoring. Let's walk through those.
Okay, first, framing. Setting the stage. Before you even look at specific risks, you define the context. What are our assumptions? Constraints. What's our agreed risk tolerance from the board? What are the business priorities? You're drawing the boundaries.
Setting the rules of engagement.
Pretty much. Second, assessing. This is the analysis. Identify assets, threats, vulnerabilities, figure out the likelihood of something bad happening and the impact if it does.
And the key output here is?
The risk register.
Yep.
Or cybersecurity risk register, CSRR. This is vital. It lists the risks, who owns them, likelihood, impact, current controls, plan of response. It's the central communication tool.
The single source of truth for risk.
Ideally, yes.
Right.
Third, responding.
Yeah.
Based on the assessment, what are we going to do about each risk? You evaluate the options.
The classic choices: accept, avoid, mitigate.
Share or transfer.
Right.
You pick the best strategy for each specific risk, considering cost, benefit, and alignment with the appetite.
And finally,
monitoring. This isn't a one-time thing. You have to continuously watch. Are the responses working? Has the risk landscape changed? Are we still within our tolerance? It's the feedback loop that keeps the process alive and supports ongoing authorization.
Now, assessing. Often it feels subjective. High, medium, low risk, gut feel. But for big decisions, you need more rigor, quantitative methods.
Yeah, qualitative is okay for initial sorting, but for significant risks, you need numbers. Subjectivity is dangerous when millions are on the line.
So what techniques can help?
One common one is three-point estimating. Instead of asking an expert for one number, like, how much will this breach cost? Which is just a guess.
You ask for a range.
Exactly. Ask for optimistic, best case, most likely, and pessimistic, worst case. Then you use a simple statistical formula, often PEAT, to calculate an expected value, EV.
So a more weighted average.
Right. And importantly, you can also calculate a standard deviation, which gives you a confidence level. So instead of, it'll cost $500, you can say, we expect 500 Ks, and we're 90% confident it won't exceed 750 Ks. Much more useful for decision making.
That definitely reduces the reliance on a single guess. What about more complex scenarios? Monte Carlo.
Monte Carlo simulation is powerful. Cybersecurity risk is messy. Lots of variables interact randomly. Detection time, records lost, fines, reputation damage.
Too complex for a simple formula.
Way too complex. Monte Carlo uses software to run the scenario thousands, even millions of times, plugging in random values for each variable based on their probability distributions.
And the output isn't one number, but
a probability distribution of potential outcomes. You can see the range of possible losses and their likelihoods. A manager can look at, say, the 95th percentile loss. There's a 5% chance this event could cost us more than $20 million.
that really helps with things like budgeting for controls or deciding how much cyber insurance to buy.
Absolutely. It gives a much richer, more realistic picture of the potential downside than a simple high, medium, low rating ever could.
Okay, moving into Section 4, we have the governance structure, the risk language. Now we need the engine, policies.
Right. Policies translate that strategic intent into day-to-day rules.
What makes a good policy? What are the best practices?
Clarity and authority are key. A policy needs to clearly state a mandatory requirement for handling information. Think acceptable use, remote access, data classification policies.
Should they be super detailed?
No, the high-level policy itself should be concise. Best practice is often a hierarchy. Policy, the mandate, for example, protect all customer data, supported by standards, specific requirements, for example, use AES 256 encryption, then maybe guidelines, recommendations, and procedures, step-by-step instructions.
Keep the policy itself focused.
Yeah, one clear mandate per policy is often best. And critically, it needs to be written in plain language everyone can understand, not just techies. And, as we said, approved by senior management for authority.
And how do you ensure people actually know about and follow these policies?
That goes back to that administrative control awareness training.
Well, it's not just nice to have, it's essential.
Absolutely essential. It's how you ensure users understand their responsibilities and formally acknowledge them. Without it, people might violate policies simply because they didn't know. Training mitigates that huge risk of unintentional human error.
You can't firewall ignorance.
Well put.
Yeah.
And policies also have to reflect the outside world laws, regulations. Compliance isn't optional.
Right. Non-compliance can mean massive fines, legal trouble. Let's touch on some big ones. GDPR.
The big one globally. GDPR in the EU fundamentally changed data protection. Mandatory rules for handling personal data, consent, transparency, data minimization, and that famous 72-hour breach notification rule.
And the fines are serious.
Potentially crippling. Up to 20 million or 4% of global annual turnover, whichever is higher. That got everyone's attention.
In the U.S., it's more fragmented.
Yeah, often sector-specific. High P for healthcare, protected health information, PHI, with strict privacy and security rules. GLBA for financial institutions, protecting consumer financial data.
And SOX, Sarbanes-Oxley.
SOX, specifically Section 404, is huge for public companies. It requires management to assess and report on the effectiveness of their internal controls over financial reporting. IT controls are a massive part of that. Security failures can become financial reporting failures.
So, lots of requirements. How do organizations manage all this complexity? Frameworks help, right? Like NIST.
Frameworks are indispensable for bringing order to the chaos. NIST provides some of the most widely used ones. The NIST Cybersecurity Framework, CSF, is a big one.
Version 2.0 came out recently. What's the key takeaway there?
The biggest change in CSF 2.0 was pulling out govern as its own core function, alongside identify, protect, detect, respond, recover.
Why was that significant?
It explicitly emphasizes that governance, setting risk tolerance, defining roles, ensuring strategic alignment is the foundation upon which all the other security activities depend. You can't effectively do the others if governance isn't solid.
So CSF is the high-level what, and then the NIST risk management framework, the RMF, is more the how.
Exactly. The NIST RMF SP 837 is a detailed, structured process. It's a 7-step lifecycle approach to managing security and privacy risk.
And it needs to be tied into development.
Absolutely. It's designed to be integrated right into the system development lifecycle, SDLC, from the very beginning. The security can't be bolted on at the end.
Okay, what are the 7 steps, briefly?
Sure. 1. Prepare, get ready. Establish context, roles, strategy, risk tolerance. Same idea as framing. 2. Categorize. Classify the system based on potential impact if compromised, low, moderate, high. 3. Select. Choose the right baseline security and privacy controls based on that category. Tailor them. 4. Implement. Put the controls in place. Build it securely. 5. Assess. Test the controls. Are they working as intended? Are they effective? 6. Authorize. This is the crucial decision point. A senior official, the authorizing official, AO, reviews the assessment results, understands the residual risk, what's left after controls, and formally accepts it, or doesn't. 7. Monitor. Continuously watch the system and controls. This supports ongoing authorization, not just a point-in-time check.
That authorize step seems key. The AO is formally accepting the leftover risk on behalf of the organization.
It is the key accountability step in the RMF process. It forces a senior leader to explicitly acknowledge and take responsibility for the security posture of that system.
Okay, final section, section 5. Protecting the actual asset, the data. Let's start with privacy versus security. Still gets confused.
Constantly. They overlap, but they're distinct. Privacy is about individual rights. The right of a person to control their own personal information, PHI. It focuses on lawful, fair, transparent collection and use.
And security.
Security is about protecting the organization's assets, data, systems, networks, ensuring confidentiality, integrity, availability, protecting the container and the contents from unauthorized access or harm.
So give me that scenario again that highlights the difference.
Okay, imagine an employee has legitimate access to customer records for their job. Security is fine. But then they browse records they don't need for their task, maybe out of curiosity.
The system allowed it, so security wasn't breached technically?
But privacy was breached. The data, even though accessed by an authorized person, was used improperly, violating the individual's privacy rights regarding how their data should be handled.
So security is necessary for privacy, but not sufficient. You need rules about proper use, too.
Exactly. Privacy governs authorized use as well as preventing unauthorized access.
Now, to protect data effectively, you first need to know what you have and how important it is. Data classification.
Foundational. You can't apply the right level of protection if you don't know the value or sensitivity of the data. Classification drives everything. DLP rules, access controls, encryption requirements.
And it's based on 2 main factors, sensitivity and criticality.
Right. Sensitivity is about confidentiality. How much harm if this gets disclosed? Think trade secrets, personal data, financial results before release.
Then criticality.
Criticality is about integrity and availability. How much harm if this data is unavailable or corrupted? Think operational data for a factory, control systems for infrastructure, real-time transaction data.
Can data be critical but not sensitive?
Sure. Public flight schedules might be low sensitivity, but they're highly critical to an airline's operations. If they're unavailable or wrong, chaos ensues.
And who does the classifying? Not IT.
No. Typically, it's the data owner, or sometimes the data creator.
Yeah.
The business person who understands the data's value and context is responsible for assigning the classification level, e.g., public, internal, confidential, restricted. IT then implements controls based on that label.
Makes sense. Accountability follows ownership.
Right. And those controls need to follow the data through its entire life cycle.
Creation, storage, use, transfer, disposal, all of it.
All of it. You need consistent protection. Encryption is obviously key, especially during use and transfer.
But sometimes you need more than just encryption, especially when sharing data for things like testing or analytics.
Yeah, sometimes you want to reduce the risk by reducing the sensitivity itself, while still keeping the data usable for certain purposes. That's where other techniques come in.
Like data masking.
Data masking, yeah. Obscuring parts of the data, like showing only the last 4 digits of a credit card. XXXXXXXXXXXXXXX1234. Useful for call centers or displaying partial info.
And tokenization.
Tokenization is powerful. You replace the actual sensitive data, like a full credit card number, with a meaningless token. The real data is stored securely elsewhere in a vault.
So the token can flow through less secure systems.
Exactly. Test systems, analytics platforms, they can use the token. If the token leaks, it's useless without access to the vault. It effectively de-risks the data for those uses.
And anonymization.
Anonymization aims to strip out all personally identifying information so that data can't be linked back to an individual. Harder to do perfectly than it sounds, but essential for some types of data sharing and research.
And finally, disposal. Can't just toss old hard drives in the bin.
Definitely not. Secure disposal and data sanitization are critical parts of the life cycle. You need processes to ensure data is truly destroyed or unrecoverable, preventing dumpster diving or leaks from old equipment.
Wow. Okay, so that really covers the journey from the board-setting strategic risk appetite down through policies, frameworks, roles, and finally to the specific controls protecting data throughout its life, like tokenization and secure disposal.
It's all connected. Governance provides the direction, risk management provides the framework, policies provide the rules, and controls provide the protection, all hopefully working together.
It really emphasizes that security has to be integrated everywhere, driven by the business needs and the agreed-upon level of risk. Hashtag tag outro. So that was quite a deep dive. We've covered a lot of ground today: strategic alignment, the absolute necessity of senior leadership and board involvement in setting risk appetite and tolerance.
Yeah, and the practical application through frameworks like NIST RMF, integrating risk management right into how systems are built and operated.
And clarifying that crucial difference between appetite, the strategic goal, and tolerance, the measurable operational boundary.
Plus those quantitative techniques like three-point estimates in Monte Carlo that help move beyond just subjective risk ratings. And remembering those limits, the triggers for escalating tough decisions.
Right. It all comes back to that idea that effective security isn't just an IT department issue. It's a business function, requiring a risk-aware culture defined and driven from the very top.
Couldn't agree more. It's a collaborative effort built on clear accountability and a shared understanding of risk.
So the ultimate goal is understanding that residual risk, what's left over after controls, so the right person, the authorizing official, can make that informed decision to accept it. Which brings us to our final thought for you, the listener.
Yeah, think about this. We've established that the AO accepts the risk, historically a formal, often periodic, sign-off event.
Yeah.
But look at the speed things move now. AI, rapid cloud deployments, continuous integration, continuous delivery pipelines, everything is changing constantly.
The pace is incredible.
So how does that traditional periodic risk acceptance model keep up? Could the concept of risk acceptance itself need to evolve? Maybe become less of a static sign-off and more of a dynamic, perhaps even automated or algorithmic function embedded right into the architecture?
So instead of periodic authorization, maybe near real-time, automated risk acceptance based on predefined rules and continuous monitoring.
Could be. Is continuous monitoring and ongoing authorization enough? Or does the acceptance itself need to become faster, more integrated? That's a huge challenge for governance frameworks going forward, something to chew on.